Our next family of visualization shows distributions, that is how the values of a variable are distributed across that variable's range. And I think a lot of them are probably pretty familiar to you, but I just wanted to point it out again, their strengths and weaknesses, and in particular, which facets of a distribution each one of these visualizations highlights. So they come in flavors, like I mentioned, that you're probably familiar with, things like histograms, box plots, scatter plots, and then density maps, which is maybe the one you haven't seen or done, I guess, maybe used as much. They're also called heat maps. But let's kind of walk our way through here casually, and we'll kind of see what's going on. So a histogram is basically the following idea. I chunk up the range of the variable into bins, and then just count the number of observations in each bin. So for instance, I've done maybe 5-year bins here, and so let's say from 72 to 78, 72 to 77 if it's 5-year bin, there were 600 observations. So 600 countries or years, let's say, fell into this particular range. And then you can get the idea then that there's a particular shape to this distribution where more countries are up here, fewer countries are down here, and then we have kind of a bimodal distribution. Maybe there's like a little group of clusters down here, a bigger group of clusters up, or a bigger group of countries up there, and so on. Now, the hard part with histograms is how many bins to use. I mean, if it's all about the, showing these bins, well, how many bins am I going to use? Am I going to use one? No, that's silly, obviously, right? Because then you just have one big block. That's not useful. It's also not useful to have too many, because then you're basically looking at each data point individually, and that's not the point. What you want to do is somehow pick the right value in the middle, and then picking the right value is really tough. It's really hard. A typical place to start is the square root of the number of bins that you have, but this is just a guideline. It's not any particular reasoning for that. Sometimes you might want to use 5-year chunks, if that makes sense, or 10-year chunks, or whatever. But notice that if I make the bin size a little bit smaller, things do change quite a bit. Now I'm seeing like, oh, actually there's a super high group, and then just a moderately high group, and there's a really low group, and then kind of a medium group, and maybe even a group in the middle. It gets a little bit more confusing, doesn't it? Like, it's not quite as clear just by changing the bin width. The data have not changed. All I've done is change the bin width. So the extent to which we kind of zoom out or zoom in here does impact our findings quite a bit. And if we zoom out even more, we get to something like a box plot. So a box plot is a very old statistical visualization technique that highlights some statistical quantities that we often care about. And I know it's a little vague. We're going to go through them in just a moment. I just want to motivate why we're doing this, because I feel a little odd, like it's 2021. Why are we doing box plots? We're doing box plots because they're actually on the Tableau exam syllabus. Like, one of the things is like, if you want to get if you want to get certified Tableau specialist or associate or professional or whatever, you have to know this. Which I found so interesting because of this like very advanced company, right? But you have to know a very classical piece of statistical visualization terminology to do this. So let's go through here. So in this box, in this box here, we have a couple of things that we can interpret. So the box itself is the most important part. Basically, the box shows at its bottom Q1 and at its top Q3. Remember, Q1 is the value for which 20 is the first quartile. 25% of all data points fall below that, and 75% of all data points fall above that. Q3 is kind of exactly the opposite. It's the third quartile. 75% of all data points fall below that value, and 25% of all data points fall above that value. And so another way of saying that is 50% of all the values in the data set fall within the box of the box plot. The median, which is the value that if you were to line them up would be right in the middle, is the line in the middle of the box plot. And in Tableau, these edges of the box are called hinges, the upper and lower hinges. It's a fairly common way to talk about it, but the particular piece of terminology. So we have the box, and then we have the whiskers. So these whiskers on the outside kind of look like cat whiskers, but not really. But anyway, these are supposed to give us an idea of kind of the outside edge of what we would consider normal. And to do that, in this particular definition, we take the quartiles, the hinges, and we go out 1.5 interquartile ranges. So an interquartile range is just the width of this box. It's Q3 minus Q1. It's the width of the box in the box plot. So I take the width of the box plot, I go 1.5 of those out, and that by fiat, by definition in this case, is the limit of what I would consider normal. Now, you can imagine changing that definition, like if you're thinking about it in terms of standard deviations, sometimes people say 3 standard deviations away from the mean, or 5 standard deviations from the mean, or sometimes 2. It's an arbitrary distinction. Regardless, though, we call things that fall outside that expected level of deviation outliers. These are atypical values and that we might want to look into more. We're not quite sure. Are they real? Are they not real? Did someone misenter something? Are they very strange months or observations for whatever reason? Regardless, it's a way of getting your head around how much of a data quality issue you might have in a particular variable. So I'll just point out that histograms don't have this kind of statistical information in them. They don't have anything about medians or means. They do. You can see the mode, the most common value. But they don't kind of break it down into a more quantitative format. So the box plot can be useful, as much as I kind of poo-pooed them earlier. Regardless of whether we like or hate box plots or histograms, one of their weaknesses is that they only show one variable. So if we want to show more than one, the distribution of, for instance, 2 variables together, we need to plot them together. We have to do a scatter plot. So in this case, I've plotted life expectancy and birth rate, both of those numeric variables. And each dot is a country in a particular year. And so we're seeing that these things are distributed together in a particular way. And that can be really useful. It can be really, really useful. And we'll talk in a future video about trying to quantify the relationship between these two. But here, we're just trying to see how they're distributed together. We don't have any further aims. We're just trying to show how they're distributed together, even if they, we could divine some kind of relationship later. And if we were to take this one step into the future, or one step farther, we might not want to focus on individual countries, but just where things are more or less prevalent. And this brings us to our heat map or density plot idea. And in this particular case, darker regions are more filled, there are more data points in the darker regions than there are in the lighter regions. And this is a way of kind of encouraging the reader not to get, or the viewer, for instance, rather, not to get too caught up on the details. It's not about the individual data points. What we're trying to encourage them to do here is kind of look at the big picture, kind of where things are in general, not individual countries or individual years, but just kind of where are things common and where are things not. And it can be really useful because one of the things that can happen when you have tons and tons and tons of data is all of these marks get stacked right on top of each other. And so you can't really tell if there's 30 marks right there or 3 marks right there, because they're also stacked right on top of each other or nearby. It's not actually clear how dense that area is. This is what the density plot is trying to get away from. It's trying to get away from looking at individual marks, and it's trying to get us to look at the density. So all of these have their particular strengths and weaknesses. Histograms and box plots only deal with single variables. Histograms, you have to worry about the bin size. The box plot, it's, there's a lot to interpret and maybe harder to walk a non-technical audience through a box plot than some of our other choices. For scatter plots, you can see the distribution, but if there's lots of data points, maybe it's not so easy and you might need a density plot. But at least we have a range or portfolio of options here for looking at the distribution of numeric variables, either singly or in pairs. In future videos, we'll, like I said, talk about quantifying a relationship or digging a little bit deeper, but we'll declare victory for now and move on.